Hello, welcome to week one of software engineering. This is our first week one video lecture, and glad to be here. And let's go ahead and jump into the deep end of the pool. Okay, software engineering. Software engineering, what is it? Okay. What is it concerned with? Software engineering is concerned with the methods, processes, and tools for professional software development. The key thing I want you to get out of this definition is methods, processes, and tools. Now, there's many ways you can build a system. You can just say, here's a picture, here, this program, and go out, program it, okay, and then when you get it done, come back and show me, okay. Software engineering is taking a little different approach. Software engineering is basically saying that we have a step-by-step process that we're going to follow. Now, later on, you're going to find out that there are multiple methods that we can use, and based on the type of application we're going to be building, that will kind of drive where we're going. But in general, looking at software engineering, methods, processes, and tools, and what those are, and how do we utilize that to basically develop an effective system that gives the users what they want. The thing that drives mostly not only software engineering but just business in general is cost. Okay, cost is what likes to be controlled. Okay, we have costs that basically on systems today that hardware costs have decreased so much that basically, I mean, you can go get you a laptop for $500, but the software that it takes to run on that particular piece of hardware is going up and up and up. Okay, so the systems that we develop have to be cost effective. So in this first bullet point, software costs often dominate computer systems costs. That is a truism, okay? It does. Software costs more to maintain than it does to develop. And just think about the reason for that is that, we might develop an application or a system, and it took us, 6 months, okay? And we start using it and we use the application, we use it for a couple of years, okay? For a good system, it might be 5, 10, 15 years, okay, that we're actually using that system. So the cost that over those times, there's going to be things that break, there's going to be changes that the user is going to want to have. So the life of that piece of software is going to go way beyond, okay, when we first develop it. So that cost, the cost to develop it is only a small fraction of the total cost when we look at maintenance of that application over a long period of time. Software engineering is concerned with cost-effective software development. ROI. Some of you probably have had business return on investment. Okay, how much do I put into a project and getting it done, into an application getting done, and what am I going to get out of it? Software engineering's concern is making sure that that ROI, okay, is as large as possible. Software project failure. Whereas software engineering may not be used in all cases for all application development, the possibility of software project failure goes up when you don't use software engineering methodology. The systems today they're more complex, they're bigger, they're better, okay, and where you could have taken a application and basically said, here, Mr. and Mrs. Program, code it. Things are so complicated nowadays that you can't do that. You have to sit down and actually plan what you're doing. Second item, if you look at a failure to use software engineering methods, says it's very easy to write computer programs without using software engineering methods and techniques. And many companies do drift in or basically say the software is so advanced that they really feel that they don't have to have software engineering. Just kind of a note, one of the things that one of the truism sayings that I always kind of fall back on is from one of the executives of, I think it was General Motors at the time. And it says that a system takes on an aura of accuracy that's sometimes turned to as a substitute for judgment. Okay? And you'll find it very true in data processing in general, that things look so slick, they work so, it looks like they're working so well that you kind of forget, the basics of what and how things should be done. That is basically what we're driving here with software engineering. Okay, there's certain methods that we're going to be using, and the methods we're going to be using are going to be trying to ensure that software engineering is used and that systems are not going to fail. Here's some myths. Keep these in mind. Okay. Testing can ensure that all bugs are found. And the answer to that is no. Testing will not ensure that all bugs are found in your application or in your program. Anyone who can program is a software engineer. Software engineering has a wide gambit of what's covered under software engineering. And a programmer who programs Java, programs Python, okay, is really not in tune with the full range of what software engineering covers. And so there really shouldn't be any expectation that a software engineer is AKA a programmer, okay, that can take care of all that. Adding more developers makes the project go faster. That's probably the opposite. The more people that you have on a project, the more communication you need, the more probability that communication fails. So that is one of the myths of software engineering. Software requirements don't change once they're gathered. We will be going through requirements very, very much so in a little later. And we're going to find one of the truisms that is true is that most users and stakeholders don't know what they want. Okay, they have this concept of perceiving of what they want, but whenever you make a presentation as to what your particular application does, don't be surprised if you say, well, that's not exactly what I thought it was going to look like, or that's not exactly what I thought it was going to turn out to be. Software requirements, okay, will change. It is one of the truisms. Software requirements will change. Once software works, it's done. Once software works, it works now. Okay. Whenever we get into a situation that is different from where we tested that particular software, it may not work. Okay. Software works. It's done is a myth. It is only saying that at this moment, at this time, we have made tests on this software, and so far we have not found any bugs or anything that's wrong with it. But again, it is not done once the software works. Good tools guarantee project success. No, not good tools. Being able to use good tools may help in getting project success. It's not the tool itself, but how you use it, when you use it, and whether you use that tool effectively. That is what guarantees or moves you toward guaranteeing that you will have success. Just some general questions, general definitions I'm expecting you to know. What is software? Okay, computer program, associated documentation. Key thing I want to highlight there is associated documentation. What I want to basically put in your ear is associated documentation. Okay. Yeah, I'm repeating it. I know that. But that's one of the things that programmers don't like to document. But that's one of the things that I'm hoping to always drill into you is when you go out there in the quote unquote real world. Documentation, okay, is something that is needed and it is something that you have to have. So I will get into that a little bit later on. What are attributes of good software? Okay, delivers the required functionality and performance to the user. Yeah, that's step one. The user says, I want A, I delivered A. The user says, I want B, I delivered B. The user didn't say they wanted anything about C, okay? But C happened, and the user's not happy, even though they didn't ask for it, okay? So looking at that, yes, our requirements will get the users where they want, okay? But it's not the all end all, okay? Good software delivers required functionality and is flexible enough to basically handle any surprises. What is software engineering? Software engineering is a engineering discipline that is concerned with all aspects of software production. Okay, all aspects. Okay, we're concerned with gathering requirements. We're concerned with modeling. We're concerned with testing. We're concerned with implementation. Okay, so there's several things in software engineering that we have to cover. Okay, to make sure that we put out a quality product. What are fundamental software engineering activities? Software specification, development, validation, and evolution. Okay. What is not shown here, and which I want you to make sure that you're kind of in tune with, is we're missing requirements. Okay. That will be the first step. Nothing in data processing works without a requirement. If you're ever given a task that says, Mr. and Mrs. Programmer, I want you to produce this, and you have no requirements, you're doomed to failure. Okay. You have to have requirements. So the first thing on this list is not really a software specification more than it is a user requirement. User requirement first, from then we move on to software specification. So just keep in mind that there's something missing in this particular slide as far as the requirement itself. What is the difference between software engineering and computer science? Computer science is more theory. Computer science is, I want this processed in, 50 nanoseconds. Okay. I want to be able to blend my colors in this color range. Okay. I want to be able to use a linked list. I want to be able to sort. I want to be able to all the common functionality that we've come to know as being programmers. Okay, that's what basically we're talking about with computer science. Computer software engineering, though, is a little bit more than that. Computer science you can consider being inside, okay, of software engineering, and not something that's really separate from software engineering, but a companion to software engineering. Okay, different focus. What is the difference between software engineering and systems engineering? Okay, so where software engineering is concerned with all gambits and the full-fledged of software, systems engineering is more concerned with everything. Software engineering is a component or sub of system engineering. In system engineering, we're talking about hardware, we're talking about websites, we're talking about data flow, we're talking about security, we're talking about, you name it, okay, the system has to take care of it. That is systems engineering. We will not be basically touching all the components of system engineering. We will be covering things that have to do with software and developing that software, okay, in such a way that it produces a viable product. Not whether we're going to use, a laptop, or whether we're going to use a mainframe, okay, or what our gig speed is, okay. Yeah, we're going to be somewhat concerned with that, but not really from a systems engineering perspective. Okay, these terms, these are terms that I'm going to be very, very, suspect on, because they're nebulous. Okay, I want my application to be maintainable. I want my application to be dependable. I want my application to be efficient. I want my application to be acceptable. Okay, Those are goals that just on the surface and you looked at them uh, are not good goals. Okay. Now, to say something is maintainable, you have to have criteria on what makes up maintainability. Okay. Yeah, in general, software should be written in such a way that it can evolve, okay, to meet the changing needs of the customer. Yeah, but you really haven't said to what effect. Okay. Well, what would be acceptable? Yeah, I'm maintainable. I can maintain if something goes wrong. I can my program's fixed to such a way that I can get you set up and ready to go in 24 hours. That's not very maintainable. Maintainable. It's as far as the user is concerned. So be careful with these particular definitions. What is dependable? Yeah, dependability includes a large range of characteristics, including reliability, security, safety, which are itself nebulous. Okay. But again, these are goals that we're going to be trying to push forward. My application is efficient. It is using resources effectively to a criteria that I want to reach. Acceptability. Okay. Yes, software must be acceptable to the type of users. I'm writing this or creating this application for a user. One of the things that we'll be talking about later on is acceptance testing, okay, which is going to help with that acceptability. Okay, it's going to put some numbers and some criteria behind it. So just be careful. Yeah, these are goals, but these in and of itself, okay, have to have some hard coded or hardcore uh, uh, statistics and goals that we want to reach to make sure that we reach the level we want to reach with them. Okay. Okay. What happens when we don't build quality systems? Some of this is like, duh, yeah, and yeah, you're right. But things to keep in mind that everything that you build is not going to be maybe life threatening, but system failures. If you don't build a system right, you're going to have crashes, outages. You're going to have breaches. You're going to have data leaks, hacking. Okay. Depending on the application, you're going to have financial losses. You're going to have reputation damage because the system that you built, okay, doesn't work. Okay. So that's going to affect you, your customer, okay, and how they perceive you. Safety risks, failures in medical. We don't want that to happen. Automotive, aviation. We don't want anything to happen bad in aviation. Okay, so the systems, everything we build for an airplane, a jet. Okay, we have to have a criteria that you software methodologies. Software methodologies. As with anything that we do in computer science, there's more than one way to do things. I want to put a analogy up first before we jump into software development methodologies, and that is programming languages. If you think about programming languages, we have C, C++, Java, Python, okay, JavaScript, and each one of those languages that we work with, okay, each have their own little idiosyncrasies. The only, Java is best used in some cases versus Python. Okay, so there's different times we would want to use a particular language. Well, with that, software development methodologies are the basically have a similar genre in that there's certain things we're going to be doing. We're going to be looking at requirements. Okay. We're going to be looking at modeling. We're going to be looking at development. We're going to be looking at testing, along with some other things. Okay. But each method, even though when we go over these, they all look different. Okay. They basically are touching the same points in developing the application. So, where and when you would use a particular method depends on the type of application you're going to be developing. And we'll kind of delve into that as the few weeks go on. We'll talk about, when would we use a spiral model? When would we use a DevOps model? Okay. So let's go ahead and jump on in. The first thing is the spiral model. Okay. First thing is the spiral model. Uh, and what I want you to know here, the basic output from the spiral model is a workable prototype. We go through the process of trying to get the user's requirements, looking at risk analysis, concept of operations. We'll go around the spiral, but what's going to be coming out, just see this dotted line here, is our prototypes. Prototype one, first pass, the user says, okay, that looks, you're going in the right direction. Okay. Then we have prototype two, prototype three. Eventually, we're going to get to an operational prototype. Once we reach that point where we have an operational prototype, then we'll basically be jumping into the steps to move it into production. Okay. So the spiral model, not really kind of hung up right now on the steps. What I want to get you to realize now, currently, is that the output from the spiral model is prototypes. Next, we have the DevOps. The DevOps model. Okay, the DevOps model has a little twist that makes it unique. And I'll start off with that is that there was a time in data processing where it was a sacred sin, okay, to try to test in production. Okay. So in a production, you have actually three different environments. You have a development environment, an acceptance environment, a production environment. You do not test in the production environment. DevOps kicks that. Basically says, look, we're going to actually use operations in a production environment to help us prove out the application. In the development environment, uh, we try to put everything in the development environment that's in production, in the operations. Okay? But it's not doable. Most of the time, it's totally impossible to have a development environment, okay, whether it's dev or acceptance, where it totally 100% mimics uh, operations and production. Okay. So since we never can totally get the development and acceptance environment to mimic the operations, many times we'll test. Okay, we'll build it, we'll test it, it works fine, and we put it in production and it breaks. Okay. What this particular model says, okay, rather than it being an accident, okay, let's do it on purpose. Okay, let's use that particular process where we're doing our development and make operations or the production environment a key part of the acceptance to make sure everything works. So when looking at it here, this is on the development side. At the end of the development side, we will release it into production, into operations. Okay. In this, now this operations becomes a key piece, okay, of our discussion and in our move. If something goes wrong, we take, what went wrong, we send it back to the development side, we plan it, we code it, we build it, we test it, okay, and then we release it back into production. So now production is, if you looked at it now, it's part of the process. No, we can't mimic production exactly like we do development and acceptance. So we're going to make it part of the overall process. Kind of novel. There's some dangers in doing this, of course, okay, depending what type of application you have. But for some applications where the risk, okay, we talked about here, okay, one of the key things is risk analysis, okay, in the spiral model. Okay. So one of the things here when we're talking about the DevOps is there might be applications where the ramifications of something breaking, okay, in the production is not going to be that great. Okay. So we can bear something in production breaking if it helps us build a better product. So that's what's happening here in DevOps. The waterfall model. Okay, the key thing I want you to remember about the waterfall model, it is plan driven. Uh, Plan driven means that I'm not going to do anything, okay, in the various steps of the waterfall model. unless everything is complete. I have planned it out. So in this particular case, the waterfall model, we have requirements definition, we have systems and software design, we have implementation, uh, unit testing, integration system. These are stepping stones. I won't start the system and software design until the requirements are finished. I won't start implementation and unit testing till system and software design is finished. Okay. I plan this out. I work it. When I come out of requirements, I have all my requirements that I needed, okay, in order to build the system. Whenever I come out of system software design, okay, I have everything that I need in system and software design, okay, in order to go ahead and start coding. The key thing about the waterfall model is that until all the requirements, or until a step is complete, it doesn't go to the next step. Problem with that is that here, when you look at the steps that it goes through, okay, each time I go through a step, there's a possibility that something could go wrong, okay? In that particular case, if I'm here in integration systems, integration and systems testing, and something doesn't work the way I thought it was, I basically go back to the beginning. And I go back to the beginning, I look at my requirements definition, I look at my system software design. Okay, I make the changes that I need, but I make the changes at the beginning. Then I go back down through the steps here. Well, you say, well, that's not very good. Okay, that is true. But this waterfall model is still one of the main models used in software development today. The reason for that is once I have all my, for example, once I have all my requirements completed, okay, I can take those requirements and I can break them up. I can send part of them to California, part of them to New York, part of them to Texas, part of them to North Carolina, okay, because they are basically complete and intact. Another thing I can do with the waterfall model is that I can't do with the other models is I can predict and give the user some timeline. If I'm working on a requirements definition and know that I have 100 requirements that I have to work on, I can estimate that, okay? Because I'm going to do all my requirements at one time, okay? So I can give the user information as to when things are going to be complete. I plan it, I send it to the next step. I plan it, I send it to the next step. Okay. So the waterfall model is good for keeping the user informed as to what's going to happen and when. Now, if we look at the other models, both the Spiral and for the DevOps, and we're going to be talking about the interval, okay, and Agile. I can't do that, okay. Most of the time, because I'm piecemealing, okay. Even with the Spiral model, okay, I'm getting multiple prototypes, okay? And I never get a real picture that I can tell the user that this is when we're going to be finished. Okay, this is when we're going to be finished. I can do that with the waterfall model. So that is one of the advantages of waterfall model. Since I'm planning everything out, yeah, I can tell the users when something is going to happen that I can't do with any kind of iterative type of model. Okay, okay, waterfall model. Next one is the incremental development. Incremental development basically, and let me tell you, you can overlap these particular methods. I can put a waterfall model as far as the steps in the waterfall model. I can put it in a DevOps. Okay, I can put it in a spiral. Okay, I can take the spiral and make it one of the steps. Okay, within the waterfall model. So there could be different underlyings that where we're using multiple methods in another method. Okay. So just want to keep you in mind that there's nothing sacred that says, oh, well, when I do incremental, I got to stay with incremental. I got to stay with a DevOps. I got to stay. I can use whatever method and the steps in that method that I need in order to make make the application the best it can be. Okay. So incremental, okay, same thing, has specification, development, validation, somewhat similar to the spiral model in that we're basically coming out with different versions. Incremental says, okay, I have 100 requirements that I planned out in the waterfall. I'm only going to take 10 of those, okay, and I'm going to work on them. I'm going to get the specifications for those 10, I'm develop those 10, and then I'm going to validate. And I'm going to come out with an initial version. Okay. From that initial version, I'm going to go to the user. And I'm going to say, Miss User, okay, is this what you want? And they will say yes, okay, or no. If they say no, we're going to go back and we're going to modify our specifications. We're going to develop, we're going to validate, and we end up coming up with intermediate versions. Okay. Similar to the prototypes. I'm coming up with a different prototype. In incremental, I'm coming up with a version, okay, an incremental development version. Okay. So that's what's being displayed here as far as intermediate versions, okay, that that we're going to be producing. We're going to be going through this process, okay, of incremental development until we reach a final version. Similar to when we in the spiral model we get to the basically production prototype. Okay. So here we're incremental. Again, with this particular method, I can't tell the user when we're going to be finished. Okay, because we're doing this incrementally. We're not basically planning everything out and doing it. Okay, we're doing it in pieces. So I really don't have a good idea in notifying the user that, yeah, we're going to finish on X date at 3 o'clock. Okay, so so incremental, doing things in pieces incrementally. Okay, taking part of the system and working on it at one time. Okay, DevOps, going through the process of using production. Okay, as a key part, okay, of the application development. Spiral model, keys on prototypes, okay, rather than on basically planning the whole system out. And then we have agile. Okay, then we have agile. Agile development methodology. Okay. Agile right now is probably the most used methodology of any of the five that we talked about. In Agile, we do requirements analysis, we do design, we do implementation, and implementation by ways programming, where we actually program the application. Testing, development, maintenance, and basically we come out with a launch. The key thing about Agile is similar to the interval model, is that we don't do everything at one time. Okay? We do the development in pieces. In fact, with Agile, we planned out on purpose that we're only going to do enough work, okay, for this development, okay, that will fit in a 2 to 4 week time frame. That is basically kind of driving how big is that interval? How many requirements am I going to get? We're going to be using Agile and taking the approach that we're going to say that we're going to have a 2 to 4 week window in order to do work. And what we're going to tell the user is how much we can do in that 2 to 4 weeks and what we're going to deliver to the user in that 2 to 4 weeks that is of value. You know, I don't want to come out of a sprint. We talk about the calendar sprint. Sprint is a development cycle. I don't want to come out of a development cycle without coming out with useful, okay, deliverables. Yeah. That is the key thing with Agile. I come out, when I come out of this process and I say launch, launch says I have created something that is of use to the user. Yeah. Yeah. Are you saying, well, am I not doing that, in all the other ones? Okay. Uh, are we? Okay, so let's go back and just kind of real quickly, okay, and we'll get a time limit. On these intermediate versions, okay, these intermediate versions, I start with initial version, version 2, version 3, version 4. That's basically says that we came out, okay, out of these interval methods, for example, and incremental methods, saying that no, we're not guaranteeing that when we come out of a given interval, okay, that is what the user wants. It's kind of a trial and error. Same thing with the DevOps. We're not 100% sure that when we go through that cycle, that we're guaranteeing that what we're releasing into production is what the user wants. We hope it is. And we're using production to basically prove that out. But it's not like what we're doing with Agile. Agile's purpose is to make sure that when we come out of this launch, that what we come out with is useful deliverables. And we'll talk a lot more about Agile, okay, coming soon. So, in looking at this, common overview, waterfall, linear, simple, good, well-defined requirements. Key thing there, I can give the users more of when things will be finished because I'm planning everything out at each step. Incremental delivers partial systems and stages. Okay. Can I tell the user maybe, maybe not, but incremental is going to be a little different in that, again, since I'm delivering partial, it's going to be hard to give a final estimate on when things are going to be done. Spiral, risk-driven, combines designs prototype. Agile, iterative, flexible, emphasize collaboration. DevOps integrates development and operations for continuous delivery. The basic differeces between the various models. Here, just kind of highlight real quick, it's waterfall model is plan-based and the basic steps, requirements engineering, requirement specification, design, implementation, okay? And then we go back, requirement change. Okay. Requirements are a key part of plan-driven methodologies. Agile, we have requirements engineering, we do design and implementation. Did it work? Okay, no, go to requirements engineering, do design and implementation. Okay. Now again, this doesn't say that within here I can't use, okay, a waterfall model, okay, in order to deliver something. That's what I kind of was relaying before, okay. So, but this is basically the high level view of a plan driven versus an agile or incremental driven process. Okay, part of agile is the Scrum. The Scrum is it's an agile method that focuses on managing iterative development rather than specific agile practices. They're really not. We're separating them here, but there's no such thing as a Scrum without agile. Okay, there can be agile without a Scrum, but they normally go together. Okay? Between the Scrum and agile, are really one. Okay, there are three phases to the Scrum. The initial phase is outlining the planning phase, where you establish the general objectives of the project design. Okay, you're going to do that for each sprint. We'll talk about the sprint here in a second. This is followed by serial sprint cycles. Each cycle develops an increment of the system. We're back to that pieces. I'm basically making sure I'm doing pieces, okay, of the system. And we're doing that via sprint cycles. The project closer phase wraps up the project, completes required documentation. That word I always want you to make sure you get, documentation. Okay. Key parts of Scrum, okay, the development team, potential shippable product. Okay, that's what's coming out of the sprint, potentially shippable product, useful. Product backlog, product owner. Okay. You can take a look at these particular definitions. Everything goes into a product backlog. From the product backlog, it's taken out of the product backlog and put in a sprint backlog. Okay. So the product backlog basically has everything that I'm going to be doing for building an application in the product backlog. I do my planning and I say, okay, I'm gonna pull this out of the product backlog. I'm gonna pull this out of the product backlog, and I'm gonna do that in sprint one. Okay. I put that into the sprint backlog. And I do some planning. I said, well, what out of the sprint can I do in the 2 to 4 weeks? So once I get that, I know what I'm going to do. I put it in process. It comes out of the sprint backlog, and we process it, coming out with hopefully uh, deliverables that are, as we quote here, shippable product increments. That's the basic flow. We're going to talk about agile a lot more in the next week or so. The next thing in some of these slides, yeah, the Scrum. Okay, daily Scrum team reviews the progress and priorities. The Scrum Master is responsible for ensuring the Scrum process is followed. A Scrum Master is not a project manager. The Scrum Master makes sure that the Scrum process is basically proceeding as efficiently as possible. Ah, yeah, this is one of those nebulous terms. Okay, uh, efficiency. Okay, but the Scrum, okay, a Scrum team, one of the things I do want you to kind of get it as far as the Scrum and Agile is that the Scrum has a Scrum meeting every day. So when you get out and get your job and you're on a Scrum team, there's a meeting every day, and in that meeting, there's three things you're going to want to make sure, and that's what needs to come out of Scrum. Okay, what did I promise to do yesterday? Okay, based on what I promised, what did I deliver? And based on what I deliver, what am I going to do today? Those three things. The whole Scrum process is based on you being able to get that type of information, okay, to the user. Okay. So one of the things to help facilitate that is that all Scrum meetings are stand up. You don't sit down at a desk or a table and say, "Well, I'm doing that, I'm doing this, I'm doing that." No, you stand up. Okay. And the purpose, that's on purpose, is to stand up to make sure that, put that realization in everyone that we don't want a lot of verb. I want to know, what did you promise to do yesterday? Out of that, what did you deliver today? And out of that, what do you plan to do today? Okay. Yeah. So, each step is something that we want to report to the user via the Scrum meeting. Okay. Driven by the Scrum Master. Sprint development and iteration. Sprints are usually 2 to 4 weeks long. They can change depending on the company. The velocity is how much work can I do in a sprint? I'm a member of the team and I can produce, 100 hours of work in this 2 to 4 week sprint. Okay, so with that, when I plan out that sprint, I'm not going to exceed the 100 hours for which I'm saying that I can do it. That's my velocity. Okay, so we're going to fill up the sprint, okay, with things to do based on the capability of the team members to do it. That is what's driving what is actually being uh, what is actually being developed. Okay, in a sprint cycle, it's based on what I can actually do. What did I promise? Okay, just here, this is basically what I relayed to you, just kind of pictorial. We review the work to be done. We put everything in a product backlog. We select items from the product backlog. We plan the sprint. Okay, when we plan the sprint, we take all that information and put it in the sprint backlog. When we're into the sprint, we pull items from the sprint backlog to be delivered. Okay, so that's being done here. And again, this is based on the velocity of the sprint team, the Scrum team. How much can I produce is going to determine how much I'm going to pull out of the sprint backlog. Okay. So here, Scrum, each day we go through the Scrum, where we are, where we're going. And then we review the sprint. Okay. And from that, we go back and review some more work to be done. We could have some things coming out of here that we could not do. We promised that we would do this based on our velocity, but we found potential problems and we couldn't deliver. So we're either going to come out with a review of the sprint, sending things, additional work we need to do, or we're going to come out with a potentially shippable software or a deliverable piece of code. Kind of a reiteration, sprints, as far as 2 to 4. Starting point is planning. Selection phase involves the project team who works with the customer. Sprint cycle. Okay, we talk about the role of the Scrum Master. Is to protect development team. The Scrum Master basically gets rid of all roadblocks to the development team, to the Scrum team. Okay, when a user comes in and has a problem, they're not going to be getting with somebody that's on the Scrum team. Okay, they're going to get with the Scrum Master. The Scrum Master is basically there to provide interference for anything that could prohibit the team from delivering what they said they're going to deliver. And if you think about that, uh, if every day, half of your time is spent talking to the user based on maybe some new idea they wanted, you're not going to be able to produce because it's going to affect your velocity. The Scrum Master's job is to make sure that things do not affect your velocity. Okay? That is the purpose of the Scrum Master. Teamwork and Scrum. Scrum Master is a facilitator. Another word for that. Whole team attends short meetings. We talked about that as far as stand up. Scrum benefits. Project is broken down into manageable, understandable chunks. Interval type delivery. Unstable requirements do not hold progress. Okay, a requirement didn't turn out the way we thought it was going to be. Rather than holding up progress, we put it on hold. We go to the sprint backlog and we work on something else. Okay, doesn't stop the process. Doesn't stop the process. Okay, first week 1 video. Take a look at it. I will be putting these slides as far as a resource on in the class. Uh, Zanzibar. Okay, we'll be putting this on here. So take a look, write down your questions, write down your notes, and we'll see you in class for those who are also in face to face. For those of you who are online, and we'll be talking about kind of reinforcing these with our discussion forums. Okay. So thank you, everyone, and we'll see you soon.